Okay, guys, welcome to Module 6. So food safety and sanitation. So this is the kind of the last of the more general modules. Now, then we're going to start, after the 4th of July, we're going to start carbohydrates, lipids, and proteins. I'm a lot more confident in those, so I'm more comfortable with those, but going to do my best. I did take a refresher class, so I am now a certified food safety something or other management instructor version 2 from the FISMA. So I learned, I picked up a few things, and so to try and stay on top of stuff. But anyway, that's what you do. Next week we are supposed to meet on Thursday, the 3rd, but that's the 4th of July, right? I'm relatively sure I could be here, but I doubt any of the rest of you will be here. So, no class next week, and that's what's on the schedule. Then after that, we'll start on carbohydrates. Oh, a correction from last week. I made a mistake. So in the class, and somebody brought that to my attention. So yeehaw. So um I think I had this, right? For the food allergen and the Federal Allergen Food Labeling Consumer Act, and it should be that. So somebody brought that to my attention. So it should be the FALCPA, not the FLA. So Food Allergen Labeling and Consumer Protection Act. Okay. So just and I think I changed the Quizlet, and I think I changed every place in the class. If you come across a place that you don't see, please let me know that something that I missed. Okay. Thank you very much for bringing that to my attention. All right. So today, what we're going to talk about is the learning objectives we're going to do have to do with food safety. So we're going to look at HACCP. So how many of you guys give me a thumbs up. How many of you are familiar with HACCP? I mean, you do HACCP. Okay. All right, everybody. Super. So that means I'm not going to spend a lot of time on it. I have a lot of stuff in the notes, but what I'd rather spend time on is FSMA, the Food Safety Modernization Act. Now, do you know that that came into existence after the books were written? So that means that there's not going to be a lot of information, at least at this point, on the exam. But I won't belabor HACCP to get it, and I'll just try and pick up some of the important parts. But if I skip over something that you want to know about, do let me know, and I will do my best to do something about that, right? But I don't like to yakety 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 and tell you stuff you already know. Okay. There are some things I'm not going to do, like I'm not gonna work on this one, identify food safety equipment. I'm pretty sure you guys know where all the fire extinguishers are and all that stuff, and the personal protective equipment and all that. So I'm not going to talk about that. Um, and I'm also not going to talk about this food service stuff, like the walk-in storage and safe cooling and things like that, right? We're not going to do that. And we're not going to spend much time on the microorganisms because there's a whole section, a whole module that I'm going to look at microorganisms on, right? So I'm going to save that for another time. And also, I'm not going to talk about commercial sterility and retorting because, again, there's a whole module on retorting. So I'm not going to do anything with that. So, but the first thing I want to talk about, and this is a question that I had in the quiz that really, Okay, something's talking to my ears. I got new hearing aids and they talk. Um, so I want to talk about the danger zone and temperatures. And somebody questioned one of the questions of the quiz, and I realized that I didn't answer that. It's a poorly written question. So it asked the temperature that you should, I think, cook stuff to. But I didn't tell you according to whom, right? According to who. So everybody has just a little bit different. If you look at the USDA, the FDA, the food code, the culinology book, the on cooking book, they all have they're all written at different times and they have a different audience. And so they have a slightly different temperatures. But before we do that, let's look at this. And I did put this in after I sent the notes. So sorry about that. But if we look at this right here, we know that sterilization is a time temperature relationship. It's a time, doesn't look any better than what I did with a mouse. I need more practice. A time temperature relationship. So the hotter it is, looking up here, the hotter it is, the faster the things die, right? So if we're up at 170 degrees Fahrenheit, and the cook, I believe for cook chill and for the pasteurization is about 180. So at 170, it just takes a few seconds to kill what we call vegetative pathogen. So that's a living one that's living, right? But then if we go down here, all the way down to the bottom down here, we can see that at 30 degrees, they die, but it could take many months before the bacteria die. So the higher the temperature, the faster they die. So if we're looking at, let's see, if we're looking at 140 up here, which is the recommendation from the 140, it takes several minutes. But we're out, food doesn't just magically get prepared and served, right? It sits around for a few minutes, right? So at 140, it takes several minutes for a pathogen to die. And at 130, it takes a few hours for a pathogen to die, right? But if we go up to 150, death is in a few minutes. So, and you can see that at 160, it's several seconds, and 170. So in other words, how do you decide, right? If they're only giving us a temperature, how do we, it should be a time temperature relationship. Does that make sense? Right? So you could say 140 or 135, right? We definitely know that this part here is the danger zone, which is a term that's not really used so much in the food code anymore. So what we really want to say is that we don't want food to stay at ambient temperature. If you're comfortable, so are the bacteria. So if we look at this other table that I put here, this is from the USDA, this one here, the danger zone. You can see that the USDA is using 140 to 40. So my question should have said, what is the USDA, right? Or what is the FDA? Or it should have been more clearer, right? So, and then it's giving here the cooking temperatures for these different things. So does that make sense, sort of? Maybe, Lynn, you're nodding, so it must not be too bad. Okay. The National Restaurant Association is using 135, right? So they're assuming that it's going to sit around on the the serving table for a while, right? And they no longer use the danger zone. They use the term temperature controlled for safety. So they don't like the term danger zone anymore. So that's the serve safe. So if I'd said in that question, what's the serve safe temperature, then you would put 135. All right. And then the on on cooking is using the FDA food code, and so they're using 41. So the question you need to ask is why 41? Why not 40? Does anybody know why it's 41? So 5 degrees centigrade is 41 degrees Fahrenheit. So that's why it ended up 41. So, does that make sense? 5 degrees centigrade. So that's why it's 41. Nothing magical there. So that's what On Cooking says. The culinology text doesn't say. So the culinology text doesn't say, but it gives the food safety spoilage, and it gives a time temperature relationship. So for non-meat items, it says 2 hours, 135. This is a cooling temperature. These are the cooling temperatures. And for meat, it's one. So again, these are the cooling temperatures and times. And that's the standard 6 hours. Really, the FDA food code is looking at a 5 log reduction of pathogens. So 5 log, each one is a 10% reduction, right? So that's really what they're looking at. And this is their table, and this is in the information that you have. So depending on your cooking time, cooking temperature, then you get your time temperature relationship. And this is what's in the food code for raw animal foods. This one here, this is what sous vide is based on. Oops. Wait a minute. Right here. So if I have a so if using this chart like this, so if it's 130 degrees and I'm cooking to 130 degrees, it's going to take 112 minutes. And this is the internal temperature once you reach temperature. So this time temperature relationship is what what sous vide is based on. So far, have I lost everybody?
Good to see there is guidelines. When sous vide first was started getting used in restaurants, there wasn't really any.
Right. Yeah. Did I misspell it, Monto?
Looks right to me.
Oh, good. You know, I don't spell very well. So, yeah. So, yeah, so there are guidelines. So those are the guidelines. One last thing that I want to bring to your attention is that when you see a microwave cooking directions, and they always have it hold temperature, right? So what we're looking at is that heated temperature of at least 165 degrees in all parts of the food, allowed to stand covered for 2 minutes. And that's, of course, because microwave cooking is very spotty, right? So you'll have one section will be really hot and the other section will be really cold. So what they're looking for is a uniform temperature. So should you be involved with making instructions for microwave cooking, be sure to include a standing time. Also, so people don't scald their mouth, right? Does that make yeah. Right? Has anybody been involved with any microwave cooking stuff?
Yeah, I worked for an equipment manufacturer for about 9 years, and uh, microwave technology was part of our portfolio.
Uh-huh. And did you guys follow these guidelines, Dennis?
Most of us, it was dependent on food and what the customers, own specifications were. For example, McDonald's might be slightly different than Taco Bell or whatever. So,
Mhm.
it was our goal just to make sure that the ovens were programmed to hit their specifications.
Okay. Okay. All right. Okay, so any questions? So what I'm really trying to say with all of this is that to get a true number, you have to know it has to be a time temperature relationship. And if it's going to be a truly good question, it has to say more than what my question said. My question said, what is the cooking temperature? It should have said, in on cooking, on page la di da di da, on cooking recommends a, cook temperature of at least 135 degrees or whatever, whatever. Anyway, so it was a bad question. So if you missed it, all of that for that. But really, again, it's always a time temperature relationship. And the hotter it is, the shorter the cook time. And we'll talk about that a lot. So probably, does anybody have any questions or comments? I feel that was a bit muddled, but hopefully not too bad. Nope, I don't hear anything. So good. All right. And I'm even looking at the chat. There's nothing in the chat, so that's good. So originally, the FDA would say, okay, you guys, I'm coming to your facility and we're going to do an inspection, and we're going to run all around your facility. We're going to check all your temperatures. We're going to check your logbooks. We're going to check all of this stuff against our regulations. And that's how they did a a food inspection. A few years ago, before FISMA, they said, whoa, that just doesn't make any sense. People don't like it. They don't know what we're going to be looking for. And so they don't know what to expect. So, and we don't have enough manpower for that. So what we're going to do is we're going to make the food manufacturer come up with their own plan. And that's what the Food Safety Modernization Act does. So the FISMA says you in your facility decide what it is that what your hazards are and how you're going to control them. And so then you decide and you create the documentation and you can create the control points. And now when we come into our inspection, we're going to be looking at your plan and your documentation to see if you are doing what you said you were going to do. Right? Has anybody been through one of these inspections? You have, Trevor. So what was it like?
So I actually designed, built, and opened a USDA inspected Wagyu brick and mortar butcher shop where we did animal processing for both what we sold retail in our facility, what we sold to restaurants locally in Houston, what we did for rcranch.com mail order steaks, and so on and so forth. Um, Writing the HACCP plans was very tedious. And then once submitting them and then getting them tweaked, I guess, or, requests for modifications and such. And then just putting the SOPs in place for the opening routine, the midday routines, the constant CCP monitoring, assigning staff to check and initial and timestamp and keeping all the records. It's a bitch.
Yeah.
To be honest with you,
Yes,
there's a lot to it.
there is a
Yes,
lot to it.
Trevor, was the process of just writing the plan months? I mean, or many weeks at least? It sounds like that's
Well, you know what? I can be completely transparent with you. Uh, the 5 or 6 years ago, when I was tasked with that chore, yes, it was very tedious and it took a long time. I actually worked with private consultants that specialize in HACCP and food labeling and the USDA and nutrition panels and ingredient panel statements and everything. But lo and behold, if I had to do it all again today, I would use chat and put all my parameters, all my needs, all my hurdles, just all the information I needed to put into an AI assistant and get a good template or outline, if you will, and then build from that.
Right. And today,
So today, if you have to write a HACCP plan, you've got technology today that's available that can pretty much get you through at 99.99%.
so yeah, and I think, Trevor, that things have changed a little bit over the last few years, and it's become maybe there's a little more assistance available on the FDA, USDA websites to help you do that.
Yeah, if you could figure out anything that ends with .gov.
Right. And I also think that having had experience with the first one, the second one would look a whole lot different.
Oh yeah, I could write one in a day now that I've done it,
Yeah,
but
yeah,
that first jump
yeah.
is a long fall.
Yeah, that's right.
And
It
it's
is.
scary.
It looks pretty easy on the paperwork, right? When you
Oh,
read about it
sure.
in the book. Ha ha ha
A
ha.
lot of things look easy, but in real life, we all know the
Right,
truth.
right. Well, that's good. Anybody else have any input, a HACCP or have, your experience with that you want to share?
Yeah, I've had to do a couple of them actually. But yeah, just to reinforce previous points, they are a bitch. Such a pain. But yeah, once you get the first one behind you, at least for us, of all things, I had an executive chef who insisted we do them for trade shows. So once you got everything figured out, and assuming all your handling processes were the same from year to year, it was pretty much just upgrading, whatever ingredients you were using or whatever products you were using every year. But beyond that, then it was pretty much the same.
Right, right. So, well, cool. All righty. Yes. So it can be very, very tedious, especially if you don't really know what you're doing. So you guys have been talking about a HACCP plan. So FSMA is a HACCP plan on steroids, right? A HACCP plan assumes that you have all your good manufacturing practices and your SOPs, your GMPs and your SOPs all in order. And then you build your HACCP plan. The food safety plan from FDA includes all of that in the HACCP plan. So it's the HACCP plan, and it includes supplier verification, So looking at your suppliers and seeing that they have a good plan in place and that they're sending you what they say they're going to send you, right? And you get all the documentation you need. Your ingredient storage, your cleaning, and the facility, your processing method. And so the processing method right there, oh dear, right here, that's HACCP. HACCP is a processing. It looks specifically just at the process. But then this goes further and it goes into the packaging and transportation. And so now you're responsible for, or the facility, not you, the facility is responsible for all the way um, from the supplier to the transportation to the person that you're supplying it to, whoever that is. And that includes your food safety plan, or for as far as FSMA is concerned. So it's bigger. So HACCP is one part of that. And so yes. Yeah. What happened? I broke it. So HACCP is it includes all of HACCP, and it had, these are the definitions, right? So it looks for a hazard. You don't have to include every possible hazard in the whole wide world. Anything that's reasonably foreseeable as a hazard, right? And you also look at the assessment of the severity or illness in the injury, right? And so we only need to address in the food safety plan those things that are reasonable and likely to cause illness or injury, not everything, right? So one of the things that I learned in this class that I took, so one of the things is this data dashboard. So this is the FDA data dashboard. So you can look up on here recalls, and it'll give you, it says, maybe, there it goes. Recalls, what kind of recalls? So what is your product? What is your product and what kind of recall? You can, I think, search this page. Maybe. Anyway, so that gives you a hint of what to look for. Okay, there's a listing of importers. So the voluntary qualified importer program. So you can find companies in here that have already met all of the FSMA requirements. And so that's kind of nice. You can look at compliance actions. So what kind of actions we're taking against which companies and where, which is kind of nice. Where's the page I really want? And then we can also look at, I think we can do, yeah, pick one of those. So there's a lot of data here anyway that you could use. So write this one down. That this is a data dashboard. So I thought that was kind of cool. Now my tablet went to sleep. How dare it? So there is a lot more, a lot of stuff available, a lot more stuff to help. Ta-da! There it is again. All right. So just kind of to just kind of give you an idea of what might be available. So you know that HACCP starts with good manufacturing practices that are followed in the plant and all that stuff, right? And then you do a hazard analysis. So you look at that, like those data tables, you look at what's been recalled and see what all the possible hazards are. And then you fill out a handy dandy little form, one of their handy dandy little forms that talks about what it is and that kind of stuff. And so listing of hazards, there's biological, chemical, and physical hazards. And I created an announcement that I sent out a little bit earlier. Do you guys get that list? So that's a table that it lists all the different kinds of hazards. The one thing that we need to know for FSMA is that allergens are considered a chemical hazard. They're chemical hazards. So then the one thing that I want to talk about is somebody complained about a question about control points and critical control points. So a control point, oh, isn't that pretty? Okay, got it. A control point is any action or activity that can be used to prevent, eliminate, reduce a significant hazard. It's generally not the last point in the process. So it's generally not the last point in the process where the hazard can be controlled. So for instance, if we think about eggs, right? Well, let's not do eggs. That's not very good. Let's think about meat. So we think about meat. So we get our meat in, it's probably frozen. So when we receive it, a control point is to measure the temperature. That is not a critical control point. That is a control point, which requires a lot less documentation than if it were a critical control point. So the meat comes in. So now we've taken the temperature of the meat. We know the temperature of the truck, and we know the temperature of the refrigerator. We know how long it's been thawed, and what temperature it was when we started to process this. All of those things are control points. Now we cook it. We cook our meat. So then if we look at a critical control point, I broke it. A ah! What'd I do? All right, try that again. There we go. I told you it was going to be rough. Okay, a critical control point is essential to prevent or eliminate a food safety hazard to acceptable level. It is generally the last place in your process that the hazard can be controlled. And the other thing about it is that it's the one that requires the most amount of record keeping, right? So that's the one where you have to have you have to have a thermometer, you have to have the little guy register it, um, you have to make sure that the thermometer is accurate, and all that, right, Trevor? All that stuff and all that paperwork, right? So the other control points don't need that much paperwork, right? You could use a data logger, for instance, for those other ones. But when you get to the critical control point, and the thing about the critical control point, it's the last place in the process where it can be controlled. So now we've got the cook. So we know how high we cooked it, how long we held it, and the temperature that we had when we packaged it. And that's a critical control point. The most dangerous part of the process is after we cook it and before we package it. So to make sure that there's no possibility that no possibility that it was recontaminated during that time. Questions? So that's the difference between a control point and a critical control point. And when you're designing your plan, be very careful to choose your critical control points very carefully because they are a lot of work, right? But when the FDA comes in and to study, to look at your facility, when they come in, that's what they're going to be looking for. They're going to say, okay, you said this was a critical control point and you were going to do this in order to make sure it happened. And then they look, well, where's your paperwork? Well, did you verify it? Was it validated? That's what they're going to be looking at when they come in. So the other thing that you're going to want to do is to establish a critical limit. So a critical limit is whatever your cook temperature is, right? So definitely, so we're going to be looking at a critical limit, whatever the temperature is that you want to cook it. And obviously your critical limit can't be too close. It needs to have a little wiggle room in it. So like a manufacturing limit. Or your manufacturing limit should be higher than your critical limit. The FDA divided foods into different categories based on their water activity and their pH, right? So based on the water activity and pH. So the TCS, remember, is temperature controlled for safety, right? So things up here in the corner, these ones right here, non-temperature controlled for safety. These are things that are acidic, right? They have a low pH and a low water activity. So pickles and things like that. So all of these things with a water activity less than 0.88. So all of these right here, water activity alone will control it. So maybe your food doesn't have a cook. Maybe your food needs to be controlled by water activity, right? pH. All of these foods right here, no matter the water activity, they have a pH or they're so acidic that no microorganisms can grow on it. So if your food falls into one of these categories that I highlighted in yellow, you can use a combination of pH and water activity to control the microorganisms. But if your food is here, then you have to find something else, right? That means that if the water activity is greater than 0.92 and the pH greater than 4.6, then we need to look at how else are we going to control that? Are we going to control it with by cooking or whatever it is? So this is how the foods are classified. So not every food has to be cooked to death. Or not every food has to have a lot of salt or sugar. Or not every food has to be really acidic. But it's a combination of those. Questions? So that's why it's really important to make sure that when you're doing your food, that you're looking at it and finding the water activity and the percentage, right? So if we look at mayonnaise, right here, it has a pH of 5.1, right? So it has a high pH, but a water activity of 0.77 to 79, which is less than 0.88. So it falls up here in this category right here. So technically, it's not a potentially hazardous food. Duh. Right? Does that make sense? Now you combine it with a bunch of other stuff, like we're going to put some celery and sorry, goodness gracious me. So going to, put some other things in there, and that's going to change the pH and the water activity level. But the mayonnaise itself, that's why it's shelf stable. Because it's mostly fat and there's very little water in there. So the microorganisms need water. Questions? This, of course, doesn't apply to the aioli that you made last night. Better put that one in the refrigerator. Comments or questions?
I believe it, but that seems weird because our chewy caramels were like 0.83. So it's weird that mayonnaise is so low for water activity.
There's very little water in mayonnaise. You know that. You only put in a
Yeah,
couple of tablespoons.
yeah, yeah, I guess. True
Yeah.
that.
Little vinegar or something, right? So anyway, it's mostly fat. So you need water for microorganisms to grow. So anyway, so the moral of that story is to look at your product and make sure that you measure the pH and the water activity, even if you don't think that it's going to be important. So anyway, so we did our HACCP. We established our critical control point where we're going to monitor. We establish our corrective actions, right? So, and what our critical limits are going to be and how we're going to monitor it. And then if something goes wrong, right? If something goes wrong, what are we going to do to correct it? And then we verify that what we said was going to do was going to control it by sending it out to a lab, maybe. And then we could validate our process by making sure that we're actually doing what we say we're going to do with record keeping and all that. Any questions? Not very well explained. But I think because you guys have a good understanding of it, I'm going to do too much with it. So one of the objectives said, how would you use this when you're developing a recipe? So if you are in the lab and you're developing a recipe, what kind of things would you consider doing when you're developing your recipe? So I'll throw that out to you. What kind of things would you think about as you know, doing your recipe development? Hmm? We
I
could
would,
we could
I
add
would,
it. Go ahead.
I'd think about packaging. Um, I would think about the nutrition panel, ingredient statement. Is this going to be a RTE or an RTC type product? Am I going to merchandise it on the floor as refrigerated or frozen? Who's my target audience or target consumer? I'm also thinking about buzzwords that are trending, how I can market it. I mean,
So if we were, yeah, so all of that, yep, a lot to think about, right? So, what about if we thought just about the ingredients? So let's say we're thinking, geez, this would be really nice if it had a peanut sauce on it. Would we
then you got to think about listing allergens, all that
yeah.
gobbledygook. When did people start becoming so allergic to everything? I mean, when I was a kid, we ate dirt and drank from the hose. Now everybody's got a helmet on.
I'm allergic to dirt.
What was that?
I might be allergic to dirt.
Oh, I know we're getting too clean as a country. But definitely, especially if you don't have any peanuts already in your facility, right? You don't want to you don't want to be introducing peanuts, right?
Well,
Because
no, because then you got to break down and sterilize your line, and every single thing that comes out of your facility has to now include manufactured in a facility that processes tree nuts and
right. Yeah.
everything.
Yes. Oh, I also did learn that coconut is not a tree nut. So coconut is no longer considered an allergen, a tree
Oh
nut.
yeah, you mentioned that last week. It's
Yeah.
and sesame's on the list now.
Sesame is definitely on the list. Yes. Sesame is on, coconut is off. So yeah. Um, that's what they told me in the class. Okay, also, if we were thinking about our process, would we how would we think about our process? If we're, like if we're looking right here at this beef stew recipe, and this is a flow chart for the beef stew. All right. So what they're looking at is a couple of things like what would be your critical control point? So I have a beef with this one because I don't think it's beef stew, right? I don't think that all of these are critical control points, but it would be up to you to decide, right? For sure, the cook is a critical control point because that's where we're going to kill the bacteria, right? Or maybe it actually should be this final cook temperature right here would be the critical control point after we've added all those vegetables and we've cooked it up really good. So let's get rid of that one. Okay. So that would be our critical control point. The cool, is that really a critical control point? If we're careful that we don't recontaminate and we pump immediately into a bag and the bag is sealed, it certainly would be a control point, but I'm not sure it's a critical control point, right?
Wouldn't though the speed at which it's cooled be a critical control point?
I think it could be.
I mean, because if it's not getting, if it doesn't get down to freezing or 41 or whatever your spec is, if it takes 6 hours to get down to 50 degrees, then that could be an
This,
issue.
this
Yeah,
is
because it's
this
got
is
to be to 70 in 2 hours.
Yeah, so this is what you would decide, right, at your
Mhm.
facility based on the food code, right, above whatever the food code is. And I should, by the way, say your state regulations because some states have slightly different rules. God forbid they should all agree, right? Mm-mm-mm-mm-mm. But that could be a control point. Definitely it's something you want to monitor, right? Take the temperature after 2 years, 2 hours, but it may not be a critical control point. But anyway, the point of no matter how you look at it, right? So it's up to you to decide. So anyway, so what they're trying to say in this diagram, a picture, whatever, flow chart, is that those things need to be taken into consideration, right? So you need to think about what your critical control points are going to be, what your control point might be. And probably if you manufacture another something or other that's very similar, you could use the similar information from your other recipes, right? So, but I think when we're looking at the learning objective is the object is to say that as we're developing our new product, that we need to keep all of this stuff in mind. All the nutrition stuff and right. We probably want to keep we want to have a target for the water activity and the pH, right? So we kind of know where we're going with that. Is there something that I missed that you could think about when you're developing your new food product? Oh, I know what ingredients, right? So since you have to have verified suppliers, right? Do you want to make sure that the ingredients come from one of those? That you don't want something odd that comes from some strange place. If it does, we have to, have to talk to the purchasing people and make sure they're willing to do that. Did I leave anything out? Okay. Well, I don't know that my handwriting got all that better. I definitely wrote more though.